Today, there's more to defense than vigilance. For to survive and to win over powerful enemy ground forces requires advanced technology that combines unmatched firepower with the speed and agility to strike quickly and without warning. On the modern battlefield, that means a special kind of warrior. The U.S. Army's Apache, a warrior on the move. Apache, fast and agile, skimming through the trees, flying nap of the earth and approaching hostile forces undetected, striking at the very last minute. Apache, the U.S. Army's AH-64A attack helicopter, built by McDonnell Douglas Helicopter Company to fight, to survive, and to win decisively on the integrated battlefield of today and tomorrow. And here are the systems, the special capabilities, the breakthroughs in technology by the McDonnell Douglas U.S. Army team that make the Apache a devastating weapons system. First, firepower. Apache is the world's first attack helicopter built specifically to deliver maximum effective firepower day, night, or in adverse weather. Its primary attack weapon is the deadly Hellfire laser-guided missile. Apache can carry a payload of up to 16 Hellfire missiles. The Hellfire warhead defeats all known armor threats, can destroy tanks and armored vehicles at standoff ranges well beyond those of other anti-tank missile systems. The Hellfire missiles may be employed independently or in coordination with ground or airborne observers using remote laser designators. Apache's primary area weapons subsystem is the McDonnell Douglas 30mm chain gun automatic cannon. It provides suppressive firepower, can easily destroy lightly armored vehicles, and provides self-protection from air threats. The chain gun cannon delivers accurate, long-range suppressive firepower, firing 625 shots a minute from its 1,200-round magazine. Another firepower option for the Apache is its payload of 76 70mm folding fin aerial rockets carried in lightweight launchers mounted on movable pylons. Apache's second breakthrough in technology is its fire control subsystem. This subsystem enables the helicopter to deliver its firepower with accuracy and efficiency and integrates all weapon systems for greater target hit probability. It pre-points weapons and computes precise ballistic trajectories, assures rapid fire control solutions. Next, a fully integrated helmet and display sighting system for rapid target acquisition and engagement. With this system, the chain gun cannon can be precisely pointed at targets by simple head movements. Apache is a true total system for battle, ready to fight 24 hours a day. An infrared pilot night vision sensor enables the crew to accurately navigate to and from the battle area and engage the enemy in total darkness. This sensor pierces the night, gives the pilot a full view of terrain and obstacles. And the heart of Apache's fire control system is TADS, the Stabilized Target Acquisition and Designation Site. Around the clock, TADS supplies fire control data for all weapon systems and enables the co-pilot gunner to engage threats day and night and at extended standoff ranges. TADS includes a forward-looking infrared sensor, a day TV, direct view optics, a laser rangefinder designator, and a laser spot tracker compatible with all U.S. Tri-Service and NATO Laser Seeker weapon systems. A lightweight avionics equipment package provides multiple secure radio communications. a Doppler navigation system, and an inertial heading attitude reference system provide accurate navigation capability. The navigation system allows the Apache crew to pre-program flight routes, store multiple target locations, and precisely navigate at nap-of-the-earth altitudes. Crew station controls and displays are grouped in efficiently organized panels and consoles designed to minimize the crew's workload. Weapons and flight systems can be set prior to takeoff. Apache is built to fight and to survive, to fight again and again. This means rotorcraft and crew survivability. The most survivable helicopter known, the AH-64A, is noted for its maneuverability and agility, ballistic tolerance, systems redundancy, crashworthiness, and reduced detectability. The Apache has very low detectability because of reduced aural, visual, radar, and infrared signatures across the spectrum. It is equipped with built-in engine infrared suppressors, an IR jammer, a passive radar warning receiver, chaff dispenser, and a radar jammer. In high-threat environments, the Apache is able to mask its position in nap-of-the-earth flight to minimize its exposure. During attacks, it can quickly mask and unmask and utilizes weapons that give it maximum standoff ranges that are well beyond the reach of primary threat weapons. Apache is ballistically tolerant because it incorporates composite armor protection, self-sealing fuel cells, redundant flight controls, widely spaced twin engines, and a transparent blast shield which separates the crew compartments. Apache is invulnerable to small arms hits and tolerant of 23mm projectiles in critical areas. The main rotor blades continue to operate for 5 hours after worst-case hit by 23mm HEI. The transmission operates for 1 hour after loss of oil, and structural members and dynamic components can sustain impacts of 12.7mm AP and 23mm HEI projectiles and continue to operate without failure. Crashworthiness features are built in. The Apache crew compartment is designed to withstand vertical crash impacts to 30 miles per hour with a 95% probability of crew survival. Designed to operate in forward battle areas, Apache requires minimum maintenance. Modular components can be easily and quickly replaced, greatly reducing downtime. Ground crews can change an engine in less than 30 minutes, replace the transmission without removing the rotor or flight control system, and can fully refuel and rearm the AH-64A in just 10 minutes. A built-in fault detection and location system continuously monitors and isolates fault conditions during ground checks and flight and provides system failure information to the crew automatically. This awesome warrior is self-deployable and ready to fight when it gets there. Equipped with new extended-range fuel tanks, Apache is self-deployable to support armed forces throughout the free world. It can fly for over 1,000 nautical miles into a 10-knot headwind with a 20-minute fuel reserve. And Apache can be ready for battle just 30 minutes from the time it touches down. Apache is air transportable in C-130, C-141, C-5A, and C-17 aircraft. Apache, battle ready and deadly. Created by the most advanced and experienced industrial team in the world. Assuring U.S. Army commanders an awesome array of firepower, day, night, and in adverse weather. Apache. To fight, to survive, and to win.
Forces must be well-trained, highly mobile, and possess the ability to rapidly acquire and effectively destroy targets at both short and long range, around the clock, and during periods of inclement weather. The Army's AH-64 Advanced Attack Helicopter is a weapon system that will do that job. total system for battle. An effective mix of advanced technology hardware, tactical doctrine, realistic training programs, and integrated logistical support will ensure the advanced attack helicopter's superior combat lethality. Aircraft weaponization includes the Hellfire anti-tank missile, 30mm chain gun, and improved 2.75 aerial rocket system. Carrying up to 16 Hellfire missiles, the advanced attack helicopter can rapidly and effectively engage multiple targets. Hellfire's warhead defeats all known armored vehicles at standoff ranges greater than any existing anti-tank missile system. Hellfire can be employed independently or in coordination with ground or airborne scout teams using remote laser designators. The Hughes-developed 30mm chain gun is the heart of the attack helicopter's area weapon system. Firing at 600 shots per minute with an ammunition capacity of 1,200 rounds, the chain gun provides accurate, lethal firepower up to maximum range. Up to 76 2.75-inch aerial rockets can be launched from pods mounted on movable pylons. Unprecedented accuracy is achieved by combining the capabilities of the target acquisition and designation site, air data, fire control computer, and integrated helmet sight display system. Rapid fire control solutions minimize actual exposure time to air defense weapons, enhancing survivability. The TADS and pilot night vision sensor enable the advanced attack helicopter for the first time to engage enemy targets at extended standoff ranges, day, night, and in adverse weather. TADS contains 3 sensors which may be used singly or in combination depending on tactical, weather, or visibility conditions. They are the day television, a direct view optical telescope, and forward-looking infrared. Each of these sensors has one field of view for target detection and another field of view with increased magnification for target recognition. The FLIR sensor, white hot, sees the M109 self-propelled howitzer like this at close range. The same target, black hot, at intermediate ranges using the medium field of view. A higher magnification with a narrow field of view shows the target like this. To simplify the crew member's workload, the fully integrated helmet display sighting system provides the unique ability to selectively point TADS, PNVS, and selected weapons by simple head movement. The AH-64's ability to fly and fight at night is clearly demonstrated in this simulated night attack. Actual PNVS imagery is presented to crew members through helmet-mounted displays. Symbology of vital flight information, including heading, airspeed, rate of climb, and torque, is superimposed on the imagery for optimum aircraft control during nap of the earth flight. The pilot, by using the PNVS imagery and flight symbols presented on his helmet-mounted display, is able to fly NOE at night almost as well as he could during the day. At the target area, the pilot transitions to a hover. Symbology is provided to maintain a fixed position during bob-up and target engagement. Aware of the target's location, the crew prepares to engage. The pilot raises the helicopter above the terrain mask. Using TADS, the co-pilot gunner acquires and designates the target with the onboard laser. A Hellfire missile is launched and tracks the laser spot until it hits the target. The target may be designated by a remote laser with the same lethal results. The pilot remasks the helicopter and departs the area, avoiding detection. Mission accomplished. The Hughes AH-64 will have a combat mission availability greater than any present-day helicopter and will provide the essential anti-tank destructive firepower to meet the Army's mission requirements into the 21st century. The advanced attack helicopter is a total system for battle.
Advanced Attack Helicopter Target Acquisition Designation System, or TADS, is the most formidable multi-sensor tactical sighting station ever developed for an attack helicopter. TADS enables the acquisition and engagement of hostile targets at maximum standoff ranges, around the clock, and in marginal weather conditions. The United States Army conducted extensive testing of the airborne target acquisition designation and pilot night vision sensor systems during its 5-year development. More than just a sighting device, TADS is a field-tested, effective, accurate, and highly dependable day-night target acquisition and designation system. It more than complements the total system for battle requirement of the United States Army Advanced Attack Helicopter, Apache. This presentation describes the operational features of the TADS and PNVS and shows the systems in use. First, let's see what the pilot sees with the Pilot Night Vision Sensor, or PNVS, during a typical nap-of-the-earth flight. This color scene shows what the pilot would see with the unaided eye during the day, flying NOE. The pilot's position is blacked out during the flight so that the only view of the world available to him is through the PNVS via the Integrated Helmet Display Sighting System, or IHADS. This is what the pilot sees using the PNVS thermal imaging sensor as he flies the same NOE mission. Now let's see the same NOE mission flown in the dark of night. The high-resolution PNVS thermal imagery clearly breaks out the detail in trees, shrubs, rocks, and hillsides. The pilot is flying NOE at night, approximately 4 to 8 feet above the ground level. As you can see, the pilot has no problem safely negotiating the terrain using the FLIR with full navigation and precision hover symbology in his field of view. The next few segments illustrate the ability of the PNVS to provide the pilot with NOE operational capability in the dark of night in conditions typically found in European terrain during extreme cold and snow. As you can see, the PNVS provides the pilot with high-quality imagery capable of breaking out trees, shrubs, fences, power lines, and terrain relief features at aggressive airspeeds as he safely maneuvers to the target area. The Apache Pilot Night Vision Sensor clearly provides the pilot with unprecedented capability to fly low and fast during the day or in the darkest of nights. The Target Acquisition Designation System for the Apache incorporates a direct-view optical telescope, a day television sensor, and a forward-looking infrared imaging sensor, or FLIR. A laser rangefinder designator, laser spot tracker, and image auto tracker complement the imaging systems. They give the co-pilot gunner absolute autonomy and accuracy and single-shot kill capability. The direct-view optical telescope provides the co-pilot gunner with a real-world color view of terrain and targets in both wide and narrow fields of view. The 18-degree field of view enables the gunner to search the widest potential target area in the shortest period of time to detect targets. Mid-range target detection is achieved by selection of the highly magnified 4-degree narrow field of view. The day TV sensor has 3 fields of view. The 4-degree wide field of view is used for target detection, while the highly magnified 0.9-degree narrow field of view is used for extended range target recognition and engagement. The 0.45-degree underscan field of view is used for enhanced automatic and manual target tracking as seen in this Spec Range Plus sequence.
Both day and night target engagement capability is available with the 4 field of view TADS FLIR sensor. The 50-degree wide field of view is equivalent to the PNVS field of view and used as a backup to PNVS and for initial target detection. The 10-degree medium field of view is used for extended range target detection. In this tactical sequence, targets are detected at twice spec range, then engaged using the 3.1-degree narrow field of view. A 1.6-degree underscan is also available for enhanced automatic and manual target tracking. The following scenes illustrate the FLIR sensor tactical capability as Apache teams engage hostile forces at 2 o'clock in the morning. During the engagements, the CPG will switch polarity, automatically track vehicles, and ripple fire Hellfire missiles while remaining well beyond hostile force range. Watch and listen as the co-pilot gunner engages targets at twice the spec range using the FLIR.
6, 5, 4, 3, 2, 1, impact.
Yeah, another
Okay.
one?
Yes, I've got all kinds of them.
Okay.
Okay. Nine, 8, 7, 6, 5, 4, 3, 2, 1. Impact. Waiting.
Okay.
Okay, 13. Beautiful shot.
Roger, 02,
10.
can service you at this time.
8.
Over.
7.
This is
6,
Manager
5, 4. Another missile. 3,
Roger.
2,
02, Roger.
1. Mark it. 7, 6, 5, 4, 3. Another missile. 2, 1. Mark it. Okay, 10, 8, 7,
Don't shoot another one.
6,
Going to have to move.
5, 4, 3, 2, 1. Mark it.
Okay, we're moving.
Okay.
As noted in the previous sequences, the CPG has the capability to track targets manually or by using the Contrast Image Auto Tracker, or IAT. The IAT provides hands-off target tracking, reducing operator workload. In this sequence, an APC is auto-tracked in FLIR narrow field of view, black hot mode, beyond spec range. The tracker locks on in all sensors and is not affected by field of view or polarity changes. This sequence illustrates image auto tracker performance against an airborne target of continually changing aspects. Tracker capability is enhanced by a linear motion compensation feature. When the target exceeds the tracker window, brake lock will occur. Linear motion compensation directs the turret to maintain the last rate and direction commands long enough for the tracker to reacquire the target and continue hands-off automatic tracking. This demonstrates the advanced attack helicopter's air-to-air engagement capability with existing onboard 30mm cannon and Hellfire weapon systems. The TADS fully complements all Apache weapon systems, including the aerial 2.75-inch rocket system, the 30mm cannon area weapon system, and the Hellfire point target weapon system. The United States Army Advanced Attack Helicopter, Apache, with the TADS and PNVS mission equipment package, ensures maximum combat capability to fly and fight, day or night, and survive to fight again.
counter the vast armor forces of the Warsaw Pact, day or night, the United States Army's laser-guided Hellfire missile provides Performance Plus. Initially, Hellfire will operate with the Army's new advanced attack helicopter, the AH-64, and will contribute significantly to the AH-64's capability for rapid engagement of multiple targets around the clock. Engineering development flight tests are proving that Hellfire's unique capabilities provide the standoff, firepower, accuracy, and lethality needed to overcome packed armor's numerical superiority. Hellfire is designed to be loaded easily and quickly by 2 crewmen. The Hellfire launcher is modular, accommodating either 2 or 4 rail carriage capacity. Electrical interface occurs automatically on loading, and attack helicopters leaving the staging area loaded with Hellfires are ready to fight. In the battle area, Hellfire provides the attack helicopter with several options for attacking targets, while assuring a high probability of survival. Hellfire-equipped helicopters can operate in conjunction with ground or airborne laser designators, as well as strike autonomously. In the autonomous mode, the gunner in the attack helicopter launches the missile and performs target designation. A short missile flight time from standoff ranges minimizes exposure to enemy fire. Offset launch is a tactic that the attack helicopter can employ with Hellfire to increase its chances for survival. Freed from having to fly a direct line of sight to the target, the launch ship can elect to perform evasive maneuvers while effectively striking its target. For increased survivability, Hellfire can be launched in the indirect fire mode. Working in conjunction with the remote locator designator, the attack helicopter can fire from a masked or defilade position. The missile acquires and locks onto reflected laser energy after launch and tracks it to impact. In the target area, Hellfire has demonstrated that it is extremely accurate. During engineering flight testing, laser-illuminated targets were consistently impacted by Hellfire missiles. Hellfire accuracy is even more impressive when you realize that the entire surface of this billboard is not the target. The missile seeker is tracking only that small portion of a target actually being illuminated by the laser. The laser is visible on this display from a silicon Vidicon camera, and the pinpoint accuracy of Hellfire speaks for itself. Unlike the level path flown by current anti-armor missiles, Hellfire's approach to the target is from a high angle. This means that the target is vulnerable to impact where it is least protected with armor. Operation at night and in periods of reduced visibility is possible through a pilot's night vision system and a unique target acquisition and designation system called TADS. TADS provides the AH-64 with greater target engagement ranges, higher accuracy, and increased survival potential, as well as night operational capability. Hellfire fully supports that mission because it is effective at night and in limited obscuration and adverse weather. Using the TADS display, the gunner can acquire the target, laser designate it, launch Hellfire, and verify target impact. Another factor contributing to aircraft survivability is the capability for laser designation of the target from remote locations. The foot soldier from a close-range concealed position can point the way to the target with the Ground Laser Locator Designator, or GLID. The pilots and gunners who will cooperate with the ground or airborne laser designators are being trained for their role as Hellfire team members. Classroom instruction by the missile contractor is supplemented with hands-on operation of the equipment in a sophisticated simulator, which provides students with realistic battlefield scenarios. The Development Test Training Detachment, Yuma, Arizona, provided additional training for the Army aviators selected to conduct operational testing of Hellfire. Surrogate trainers, supplied by the Hellfire contractor, serve as interim real-world system substitutes for the AH-64 helicopter and the Hellfire modular missile system. Besides the aircrew, Army personnel were also trained using physical teardown and evaluation to perform the on-site system maintenance during the test period. Operational testing of Hellfire was completed in July and was very successful. Using operational scenarios, the battlefield capability of Hellfire was demonstrated, including night launch and rapid and ripple fire. Designation for the laser-guided missile was performed in the autonomous mode from remote airborne positions and from the ground. To increase Hellfire's mission flexibility, development is underway to provide additional guidance modules. The modular missile system will take advantage of the latest technology developments in such areas as millimeter wave and infrared for the advanced seekers it needs to continue challenging the packed armor threat. Hellfire's flexibility is also extended to launch platforms. The development of Hellfire on the AH-1G establishes the Army's Cobra helicopters as proven carriers for the modular weapon system. The Marine Corps has already formally stated its requirements for Hellfire to be carried on their Sea Cobras. The Army's utility helicopter, the UH-60, is also being considered as a potential launch platform for Hellfire. The Air Force is interested in Hellfire for fixed-wing application and has funded studies to evaluate the weapon with their close support aircraft, the A-10. Wheeled and tracked vehicles such as the M113 Armored Personnel Carrier are capable of launching Hellfire in the direct or indirect fire modes. Hellfire's modularity and its versatile fire control system make it very adaptable to the battlefield environment. Hellfire's accuracy and lethality make it very affordable for today's modern Army. It's adaptable, it's affordable, and it's ready for production. For the advanced attack helicopter's 24-hour mission to kill tanks, Hellfire provides Performance Plus.
During the summer of 1981, the United States Army Combat Development Experimentation Command, at the request of the United States Operational Test and Evaluation Agency, conducted Operational Test 2 of the AH-64 Advanced Attack Helicopter. The test provided data to support an independent evaluation of the operational effectiveness and operational suitability of the helicopter to assist the Army Systems Acquisition Review Council in a production decision. The AH-64 is the first Army helicopter developed specifically for an anti-armor combat role. It is designed to operate in day, night, and during adverse weather conditions. Special research and development emphasis was placed on creating a helicopter that could operate for long periods in the field without extensive fixed maintenance and repair facilities. This tandem seat twin-engine helicopter has redundant flight controls, self-sealing fuel cells, armor plating, and ballistic protection for critical components, providing high inherent survivability. The point target weapon system for the AH-64 is the Hellfire laser-guided anti-tank missile, which provides the aircraft with a capability to destroy enemy armor well forward of friendly ground forces. Area suppressive fire is provided by a 30mm chain gun and by 2.75-inch folding fin aerial rockets. The Target Acquisition and Designation System, TADS, and Pilot Night Vision Sensor allow the aircrew to search, detect, identify, and engage targets, as well as fly at night and during poor weather. The primary objectives of Operational Test 2 were to obtain data to assess the effectiveness of the AH-64 in an operational setting, including mission performance, responsiveness, flexibility, and weapons compatibility. To obtain data on the helicopter's reliability, availability, and maintainability, RAM, and supportability, and to obtain data to assess survivability in an operational environment. Limited data were collected on the AH-1S tow Cobra during the test to provide comparison data. The AH-64 section consisted of 3 attack helicopters and 2 scouts. Surrogate AH-1 Cobras equipped with the Airborne Target Acquisition and Fire Control System represented the yet-to-be-developed Advanced Scout helicopter. The baseline section consisted of 3 AH-1S helicopters and 2 OH-58 Scouts. Delta Company, 7th Combat Aviation Battalion, 7th Infantry Division, Fort Ord, California, provided flight crews and maintenance support for both the AH-64 and AH-1S baseline sections. The test had 3 phases: training, non-live fire, and live fire. During the training phase, instructors from Hughes Helicopters Incorporated conducted transition training for operators and maintainers of the AH-64 and its subsystems. Individual training, attack helicopter gunnery training, and team, section, and unit Army training programs were also conducted during this phase. Army personnel monitored the training to assess the adequacy and quality of instruction, publications, and training aids. The non-live fire phase began with a series of blue versus red, force-on-force engagements with real-time casualty assessment. Engagements were conducted by both the AH-1S and AH-64 sections under the operational control of a friendly ground maneuver unit. The friendly ground unit consisted of a tank platoon conducting an active defense against a company-sized armor threat force with supporting air defense artillery threat simulators. Enemy situations were passed from the maneuver unit to the attack helicopters using target handoff procedures established by training and doctrine command. Specific target arrays or priority individual targets were passed to the attack helicopters by the scouts or team leaders. The scouts maintained continuity of the attack and enemy contact. Fire support teams equipped with ground laser designators, aerial scouts equipped with artifacts, and other AH-64s all provided remote designation of targets for the AH-64 section. The various mission scenarios required attack helicopter teams and fire support teams to communicate and coordinate their actions as closely to tactical reality as possible. Both day and night trials were conducted. The terrain was varied between the Nacimiento and Gavilan valleys. To provide a realistic threat to the helicopters, the U.S. Army Air Defense School at Fort Bliss, Texas, provided air defense artillery threat simulators to the attacking forces. These ADATS systems represented Soviet SA-9, SA-8, and SA-7 missiles, BTR-60 command vehicles, and ZSU-23-4 gun systems. One-on-many trials pitted a single helicopter operating independently against an attacking force. Data were collected on the time required for each helicopter to unmask, detect, identify, and engage a target, and remask. Testers conducted several sub-tests during the non-live fire phase. Early in the test, the AH-64 was prepared for and flown in a deployability demonstration from Yuma, Arizona to Fort Hunter Liggett, and then returned to a mission-ready status. Data were collected on the AH-64's target acquisition and designation system and the Cobra's tow sight, augmented with forward-looking infrared in a side-by-side test. This subtest generated data on the ranges at which each system could identify different types of targets under a variety of light conditions and through dust and smoke. During the relative detectability subtest, both the AH-64 and the AH-1S Cobras presented themselves in front, three-quarter, and side views, while soldiers, using several different methods, tried to detect them. Data collectors recorded the times needed to detect, identify, and engage each helicopter type. Live fire testing applied only to the AH-64. During this phase, crews fired 12 Hellfire missiles with inert warheads at a simulated enemy force under conditions similar to those used during the non-live fire exercises. The helicopters fired at remotely controlled target vehicles, M47 tanks fitted with radio receivers, servo mechanisms, and a computer pre-programmed to follow a path through a radio frequency grid. 6 of the Hellfire missiles were launched at night. Maintenance for the AH-64 through intermediate level was performed by the using unit or by the maintenance company personnel. Contractor technicians assisted with higher level maintenance as necessary. Throughout the test, a sophisticated instrumentation system monitored and recorded events as they occurred. The range measurement system consisted of fixed ground transmitters, relaying data between transponders mounted on the player helicopters and ground vehicles, and a central computer. The system continuously monitored each player's location and movement, and provided a second-by-second record of significant activities during each trial. Real-time casualty assessment was accomplished by using lasers to simulate gun or missile fire. Laser designator detectors and data from the range measurement system. Videotape machines in the helicopters recorded gunners' sight pictures, cockpit conversations, and radio communications for post-trial playback and analysis.
And Romeo 3, this is Romeo 1. Romeo 1, I believe shifted to other target. Do you have vehicle at this time? Over. Red, give you now. Shot out. Missiles out. Missiles on the way. And impact. That's a good one.
During all phases of the test, qualified RAM data collectors recorded equipment failures, repair times, parts used, and other maintenance and logistics activities. All data were verified and entered into OTIA and Infonet computers to establish a database for further analysis. The final test report of Operational Test 2 of the AH-64 Advanced Attack Helicopter provides data for an independent evaluation of the system. Supporting documents are on file at the United States Army Operational Test and Evaluation Agency.
What do you think of the American exhibit at this air show?
I think the Americans are looking good here at the air show, generally speaking. It shows the vitality of the free enterprise system. We're competing here with a lot of state-owned corporations, and I think we look good.
Congressman, what do you think of the air show?
Well, I think it's very good. I've mainly, of course, been interested in our own pieces of equipment, and we saw the Apache fly yesterday, and it was just did a beautiful job. Seen the Northrop F-20 fly, our export plane, I think they did a great job. The Harrier, which of course we're going to be using in our Marine Corps, the upgraded version, it flew yesterday, and I think people saw what it can do as an attack fighter. So I think the show has been very productive as far as my committee is concerned.
A small correction, if you please. It's 92.3 megacycle. Coming from the north of the field, the AH-64 Apache, an advanced attack helicopter produced by Hughes, United States of America. Arrivant maintenant à la verticale du terrain, le AH-64 Apache, hélicoptère d'attaque avancé produit par la maison Hughes des États-Unis d'Amérique. This tandem two-seat arm helicopter is able to perform a full day, night, or adverse weather anti-armor mission. Its flexible armament is such as a 30mm chain gun automatic cannon with 1,200 rounds, 16 L5 anti-tanks missiles, and so on. Eastern General Electric T-700 turbine of 1,536 chef horsepower per unit. The Apache has a cruising speed of 158 knots. Le AH-64 Apache est un hélicoptère armé biplace en tandem. Il est capable d'exécuter des missions de nuit ou par des conditions météorologiques de vol aux instruments. Son armement multiple comprend un canon de 30 mm automatique avec 1200 obus, 16 missiles anti-chars Elfire et diverses autres armements. Il est équipé de 2 General Electric T700 d'une puissance unitaire sur arbre de 1150 kW. Et sa vitesse de croisière est de 293 km/h. The AH-64 Apache flew for the first time the 30th of September 1975. Pilots are Mr. N.V. Mosley and Schlott. Rappelons que le H-64 Apache, hélicoptère d'attaque avancé produit par Hughes, a volé pour la première fois le 30 septembre 1975 et qu'il est présenté par messieurs N.V., Mosley et Schloss. States of America.
Mr. Marchetti, you work for Aerospatiale. What do you think of this plane here? That's an American-built plane.
It's a nice plane. A nice plane. I'm just looking. I think it's a new generation of military helicopters. That is my opinion. The flexibility, the speed, a lot of changes, but especially I think for military use. And I think it's a big progress.
You think it could be used in Europe?
It can be used everywhere, not only in Europe, everywhere.
After seeing this helicopter flying, and by my own experience in piloting this helicopter, I can tell you that this is a very modern ship which can be used in the European role very good, very well.
Thank you very much, gentlemen. Mr. Taylor, as the editor of Chain's All the World's Aircraft, what do you think of the Apache?
Well, it's a quite remarkable aircraft. There's nothing like it in the world. It's one of the aircraft the West needs particularly as a tank killer.
Could it do its job in the central regions of Europe? Let's see, employed by any European force?
There's no doubt about this, because it's an all-weather aircraft to a large extent, with a pilot's night vision sensor. It can be operated at night. One of the problems we've had for years is that too many aircraft on the Western Front in Europe, Central Front, are not all-weather aircraft. We believe that the weather in Europe makes this fairly necessary.
What are the very outstanding new features that you actually see on this thing? What is new? What makes it so special?
It's designed for the job it has to do. It is a weapon platform. It's got a very, very heavy armament, just what we need to destroy tanks. It's survivable. It's got all-weather equipment. It's a very narrow fuselage, making it an extremely difficult target for ground fire. I think it's got everything that this type of aircraft needs, everything that we would ask for.
Which one has the best flying qualities, so that it's fairly fair as far as competition. But we always feel that back of this, if we don't win a military competition, back of it we have a steady commercial program.
To unveil your first new generation advanced attack helicopter. Our honor guard from the Arizona State University ROTC program. Ladies and gentlemen, the U.S. Army's first Apache production helicopter, 2 months ahead of schedule.
The U.S. Army began not only an assessment of its needs for the future of NATO, but also a painful evaluation of the lessons it had learned in Southeast Asia. The new Apache attack helicopter is one product of those studies. Its primary mission is an old one in the European arena, stopping enemy tanks. But it has been designed to perform that mission with new technologies that almost belong in a Star Wars fantasy. We are aware that this weapon system has had its share of critics. But our intent in the series of reports is to discuss neither the prudence nor the cost-effectiveness of the Apache. As has always been the practice on the science column, we shall instead concentrate on the technology of the machine and its potential peaceful applications.
The battlefield. It's the proving ground for the Army aviator and his aircraft. Recently, the Army's newest and most advanced attack helicopter, the AH-64A Apache, was fielded in what the North Atlantic Treaty Organization's leaders call the most realistic test to defend Western Europe. Reforger, Certain Strike, 1987. The annual exercise known as Reforger, or Return of Forces to Germany, and its follow-up field training phase, Certain Strike, set many precedents in the fall of 1987. It was the first time the United States sent a full corps and air cavalry brigade in this NATO exercise's 19-year history. This involved transporting by a combination of sea and airlift 35,000 servicemen, tons of equipment, thousands of tanks and vehicles, and 130 helicopters belonging to 3rd Corps based at Fort Hood, Texas. This exercise marked the debut of the advanced attack helicopter in the NATO environment. The 1st and 2nd Attack Battalions of the 6th Cavalry Air Combat Brigade, consisting of 18 Apaches each, with additional OH-58 Scouts and UH-60 Blackhawks, took part in this realistic demonstration to reinforce our European allies and practice a possible wartime role of countering a Warsaw Pact strike into northern Germany. An additional 2 operational readiness float Apaches were deployed in support of each battalion. In essence, Reforger practices deployment, war-fighting doctrine, and tactics in support of our NATO allies. Transportation is a key element of this exercise. 3rd Corps equipment left Fort Hood by convoy in mid-August for the port of embarkation at Beaumont, Texas. The 6th Cav's 38 Apaches, with other Fort Hood aviation units, flew to Beaumont in small groups to prepare for shipment overseas. Groups of 3 Apaches were prepared for shipment by partial disassembly at the port facility. This involved removing the blades and the Air Data Sensor System, or ADSS. This work was performed by the soldiers of the 330th Transportation Aircraft Maintenance Company General Support, which is part of the 34th Support Battalion. The 330th's mission is Aviation Intermediate Maintenance, or AVIM, for Fort Hood's attack battalions. As the Apaches landed and shut down their engines, crews and a support vehicle would begin deblading each Apache. As each of the composite blades were removed, they were placed in protective blade boxes along with the blade pins. Each box was then numbered for identification purposes. Helicopters were then towed to the port warehouse facility where each partially disassembled airframe was prepared for shrink wrapping. As the loadout events progressed, a Soviet merchant tanker loaded grain and presumably intelligence from a nearby quay. Specially designed mooring pins are then mounted on each side of the AH-64's fuselage. These pins are used as tie-down points for securing each fuselage to the deck of the transport ship. To protect Army helicopters during their sea transit from corrosion due to salt air and spray exposure, special polyethylene heat shrink film is applied to the fuselage, literally cocooning the aircraft in a protective wrapping. Before this is done, the aircraft is thoroughly washed to remove any excess dirt and oil. Clean aircraft achieve the best results. In this case, each Apache was washed down before departing Fort Hood. Aircraft are also tested with a combustible gas indicator to check for fuel vapor leaks. Fuel tanks are half full for shipment. All fuel filler ports, vents, drains, and battery vents are also sealed prior to applying heat shrink plastic. All heat-sensitive areas on the AH-64 are wrapped with insulative foam cushioning material. Some of these areas include the main and tail rotor areas, plexiglass windows, cannon pods, 30mm chain gun, the TAD pinvis nose area, and the horizontal stabilator. Sharp edges and protrusions on the aircraft are also covered, preventing high stress points on the film after shrinking. Cushioning material is held in place with threaded tape. The Air Data Sensor System is individually wrapped, sealed, and stowed by strapping it in the cockpit, protecting it further during transit. Heat shrink plastic sheeting is cut in sections from bulk rolls which are held together with heat shrink tape or spray-on adhesive. They are then fused together using a heat cannon. The propane-operated heat cannon produces an even 750-degree Fahrenheit flame, which is applied 8 to 12 inches from the plastic using a sweeping motion. The operator, wearing leather safety gloves, gently pats the hot plastic smooth after each sweep. As the plastic cools, it shrinks to about 25% of its original size, effectively sealing like a glove on the fuselage. Large void areas, like the space between the forward stabilator and the engine cowls, are either tied down with polyester strapping or individually covered. They are then fused to the main plastic sheeting. With no hard and fast procedure for this process, each aircraft's plastic wrapper differs slightly in appearance. Besides white, variations of lighter weight blue plastic were also used to compare the durability of each. Teams of soldiers working in shifts around the clock resulted in an average cocooning time of 2 hours per aircraft. When cocooned, the aircraft's tail number is painted on and a shipping tag is applied. The final step is the application of fuel and battery ventilator caps. A small slit is cut in the area around each vent and each of the seals are removed. The plastic is then repaired. Adhesive ventilator caps are then applied, allowing air to flow through the helicopter. The wrapped Apaches began loading on schedule aboard the U.S. Navy's fast sealift ships, Algol and Capella. A special crane cable device is bolted to each of the Apache's main rotor mount. Designed to bear the weight of the helicopter, this cable is attached after cutting away any excess plastic. Guy lines are also tied on the fuselage to guide the helicopter from the pier into the ship's cargo hold. Using extreme caution, each Apache is carefully hoisted and lowered on board. Clearance through the main cargo hatch was a matter of feet, and it quickly became evident that the slightest mistake here could severely damage the aircraft. Before loading began, dock workers and stevedores were briefed by Army officials on the need for handling these aircraft carefully. Crews quickly discovered that once the helicopter was safely lowered in the cargo hold, there still were other problems to contend with. The ship's hydraulic towing devices, which were supposed to speed the parking of each aircraft, would not operate and were discarded. Relying on manpower, soldiers and contract stevedores pushed and pulled each aircraft with its ground handling bar to each designated space. Sometimes those spaces did not allow for any room for error. Like clockwork, each Apache was chained to the deck of the ship utilizing the mooring pins. Blade boxes were either driven on board utilizing the ship's roll-on, roll-off ramp or hoisted using the ship's cranes. Back at Fort Hood, the Apache's Computerized Electronic Equipment Test Facility, or EETF, is readied for shipment to Reforger on an Air Force C-5A aircraft. The purpose behind the EETF's deployment was to get a realistic assessment of its capabilities in an FTX environment. This will assist in determining the support capability of the facility itself. This was the first time that an EETF had been air transported, and this documented experience will be used in the writing of the loading procedures training manual. With loading completed, the ships and aircraft begin the trip to Europe. Sailing time is 5 days. On board, designated Army Aviation Escort personnel daily inspect the precious cocoon cargo as an added precaution against corrosion. Any damaged wrapping is quickly repaired. The ships discharged their cargo in Rotterdam, Holland. Hoisting cables were attached to the main rotors of each wrapped helicopter. Slowly, each airframe was lifted out of the ship's cargo hold and placed on the pier. Simultaneously, the blade boxes were also unloaded. As the first Apache was unloaded, a small problem became apparent. Several of the Dutch towing vehicle's hitching devices would not fit the Apache's towing bar. A small utility tractor was located and pressed into service. Each helicopter was towed to a pierside warehouse facility where they were parked and then stripped of their protective plastic wrapping, using a specially designed knife to protect the airframe. Unloading damage was limited to 2 Apaches. In each case, the damage occurred in the rear stabilator. This particular aircraft was parked inside the hold with its brakes on. Its chains had been removed, and the helicopter apparently slid across the wet deck into a stanchion, crushing the left side of the stabilator. The other damage resulted from scraping the stabilator against the ship's bulkhead. The crushed stabilator was removed and replaced with a spare in Rotterdam. Repairs to the scraped stabilator were also done at the port. Before the partially dismantled helicopters were reassembled, the 6 calves Apaches responded to a safety of flight directive concerning a thrust bearing failure in the tail rotor swash plate assembly. As each swash plate was inspected, a determination was made to either replace it at the port or fly to the maintenance staging area, the Dutch air base located at Eindhoven, to conduct the remaining changes there. At the port complex, the aircraft were reconfigured for flight. This process included reinstalling the ADSS and the blades. Part of the blade installation procedure requires checking each blade pin's tension to meet flight specifications. The mooring pins are also removed and stowed for reuse on the return trip. After fueling, flights of 3 aircraft departed at various intervals for Eindhoven. Both squadrons remained at Eindhoven until the safety of flight message was lifted and their international flight release was approved to depart for the certain strike staging area located at Münster, West Germany. While both squadrons deployed for Münster, the Air Force C-5 carrying the EETF was unloaded at a German airbase and then driven to its assigned operational area at Wunstorf. When configured, these vans form a totally self-contained facility doing aviation intermediate maintenance with its automated maintenance programs known as test program sets. During Reforger, Army technicians diagnosed a total of 19 Apache line replaceable units, or LRUs, and returned 8 repairables to the supply system. They included the Hellfire missile launcher, TAD's night sensor, and the PNVS or PNVS. Heavy rains in the FTX staging area near Münster turned the designated landing sites for the 6 Cavs helicopters into swamps. In many cases, the Apache's landing gear sank in the soggy terrain. An innovative quick-fix solution was found by placing boards underneath each of the wheels. Despite the adverse weather, unit aviation maintenance was conducted around the clock. The 10 days of war games, dubbed Certain Strike, required constant mobility for each Apache squadron. Operations in the Lower Saxony area of Germany near Hanover offered the opportunity for the Army to evaluate the AH-64A in a tactical environment.
We showed an availability ranging from 83% to 100%. On 2 consecutive days, we had 2 entire attack battalions fully up 100%. The pluses on the weapon system, we could show we could fight the airplane at nighttime using the forward-looking infrared systems, both the pilot night vision sensor and the target acquisition designating site sensor in the FLIR system there. We were able to use those systems to, 1, identify, locate, and acquire and destroy targets at long distances. Plus, we also use the aircraft for deep strike missions of 100 to 120 clicks inbound across the FLOT. Not an all-weather fighter. It will fight in some marginal weather. Logistics-wise, I think we found we could support the airplane. I think more importantly, we found that the weapon system is maturing and the crew members are able to maintain the airplane. I think the system exceeded itself, maintaining the availability figures we have, flying the missions we've flown, and I think that's again credit to, 1, the aircraft, and just as much credit to the personnel who have to maintain the airplane along with those crew members who have to fly it.
Even mishaps demonstrated the durability of this attack helicopter. This helicopter's 4 main rotor blades struck a tree during a night mission. Yet the unit maintenance officer flew the aircraft back to headquarters support troop. All 4 blades were replaced and the aircraft was back in action in less than 24 hours. By maintaining an innovative close liaison with the Army's Aviation Systems Command, AVSCOM, in St. Louis, requests for spare parts and other technical assistance were expedited with an average turnaround of 48 hours. The Apaches led the battle during Certain Strike, preparing landing areas, clearing areas for infantry and armor, and taking care of enemy artillery with its awesome array of weaponry.
Well, the 30mm cannon is the largest size cannon or gun that we've had on attack helicopters in the U.S. inventory and Allied inventory. It has rockets on it that are capable of carrying a variable amount of fuses depending on the target situation. And then the Hellfire missile, which is not a wire-guided missile as we have had in the past, but is a laser-guided missile, which goes and seeks in on a spot that has been designated by an infantry soldier or by another Apache or by a scout helicopter. And it's able to launch its weapon systems autonomously by itself. This is the greatest thing that's ever happened to Army aviation. It has the greatest target acquisition systems, safety systems built into it. You're never bored flying this, and we're always at the front.
Significant contributors to the AH-64's fielding success were those in support maintenance, the Aviation Systems Command Unscheduled Maintenance Sample Data Collection Program, logistics assistance teams, contractor field service representatives, and the Apache Transition Team, which functioned in a supervisory capacity of these groups to assist the 6th Cav. At certain strike's end, the first of the 6 headed north to the German port of Bremerhaven to begin their trip back to Fort Hood, Texas. The second of the 6 flew their 18 Apaches to their new home base east of Nuremberg. This cost-effective move was timed with the exercises and is part of a restructuring program designed to increase the aviation capabilities of overseas corps and echelons above corps. Reforger Certain Strike 87 provided a glimpse of Army aviation's future role in defending Western Europe. By successfully fielding this aircraft, the Army plans to eventually have 13 more AH-64A units in Europe ready to fight, survive, and win.